Today we'll cover fuzz testing in the Go language. So I recently discovered fuzz testing and it piqued my curiosity. Basically, I'm a verification engineer for the last 10 years. So in hardware verification, we use sophisticated methodologies where we provide randomized inputs into the model under test. So I saw the Go fuzzing feature and I wanted to explore it a bit. So this video is just me kind of introducing myself to fuzzing and my impressions. So with fuzzing, you can do a normal test. You can run this test, this sample test, which is just for exploration of what fuzzing does. It can run as a normal test. So I can just go and run it as Go test and it will pass. Or it can run as a fuzz test. So I'll run it as a fuzz test and it'll start running. And basically it uses all my CPUs, 12 CPUs, and it randomizes the input and it just keeps running until I kill it or until it fails. Okay, let's back up a bit. So how do you create a fuzz test? So this uses like a normal pattern for tests. We have a test cases, table testing, we have a test cases. And then in a normal test, we would just run through all these test cases. In a fuzz test, what you do is you create a seed corpus. A seed corpus is basically your initial inputs into your test that you want to test. So in this case, basically I convert the test cases into the seed corpus using this add function. Add. It can provide any arguments, so these arguments are the things that will be randomized. Now, in reality, the pattern I used here is just like the test case is like a normal test you would do, but since we have to add everything anyway, you could just use this pattern, just on each line, just do an f add. And one thing to note is you can't really name this test. Maybe you can put a comment like empty string, but you can't really provide a name for this test. So after you populate the seed corpus, you run this fuzz function, and the inputs to this fuzz function is the testing struct, and then your two types that have to match these types. And then here you do the actual test. Now this is a dummy test, so it doesn't actually do much. Another thing I forgot to mention is that the fuzz test has to be prefixed with a fuzz, and instead of the testing.t struct, it uses the testing.f struct. Okay, so let's see what happens if this test actually fails. So I'm gonna just make it fail on something. So let's run it with fuzzing and see how fast it fails. Pretty quickly. So it fails, and the failing, it even tells me the failing input is written to test data fuzz sample, blah, blah, blah. So this 57725E, I can go in here. It's not refreshed, but basically all the failing tests are here. So let me show a sample one. And it becomes part of your seed corpus, right? So initially you added test cases, but then once tests fail, they're added to this test data fuzz, your test name directory, and they look like this, where byte is the first input, string is the second input. And you can see here, interesting pattern. I had a test case where I was making it fail, where the second character is A, but you see everything else is 0. So it looks like fuzzing follows some kind of sequence. It starts with 0 and then probably increments. So it's not completely random. It follows some kind of pattern, and I haven't dug deeper into exactly what that pattern is. And in fact, that's one of the issues, which I will get to a little later. So if you want to, you keep going, you fix these, and you keep going, and your seed corpus gets bigger and bigger. So once you're ready to actually, once your function is done, you're ready to check all this stuff in, you check in your fuzz test, and you have to check in all your seed corpus. So all these files over here. Alternatively, you can look at each one of these files and you can convert this into a f.add method, like f.add. What would do we here? 1 and A, unit 1, whatever that input is. So you can manually go through these and add them here, which is, to be honest, kind of a pain and also an issue. Okay, so what are my initial impressions of fuzz testing? So it appears to be a pretty good approach to help the development of small functions with limited scope. If I go to this documentation for fuzz, it mentions that the function under test should be fast and deterministic. So it's basically telling me that it's only good for functions that have limited scope. So I do plan to give fuzz testing a try the next time I'm creating a new functions and methods, and I will report back. I do, however, want to circle back and mention a few concerns and issues I have with fuzz testing. It certainly seems like a good initial approach, but it is limited in features and usability, right off the bat, right? It mentions that the test should be fast and deterministic. Well, those functions are pretty easy to test, and they're good examples for students learning how to code. But in real projects, we want to be testing things that we know might fail. Like we want to be testing things that are flaky in our continuous integration environment. We want to be testing things that are accessing remote resources in parallel, such as APIs or databases. We want to be testing things with asynchronous code. So we really want to bang those methods, those use cases a lot with random inputs, and not just a simple function with limited scope. Secondly, and this I mentioned earlier, is the randomization isn't guided at all. I'm just calling fuzz, and under the hood, it does the randomization without any guidance from me, right? But what if I have an input that's a percentage, right? I have uint 32% here. Reversed percent. And I know that most of the time I want this value to be between 0 and 100. And only rarely do I want it to be testing, outside that range, because outside that range, I just need to hit it once or twice to make sure my validation works. But basically I want the test to focus on that range. So I don't want to waste CPU cycles. I mean, UN32, it's a pretty big number, and most of the range falls outside the range of my interest. And just imagine if I had like a bunch of inputs. Maybe I have total int, other string, etc., etc. With each input that you're adding, right, you're exponentially increasing your state space, right? So if it's just one number, it's like this, right? If you add another string, then it quadruples. Another percent. So basically you're multiplying everything. It gets even bigger. So with each input, your space gets really large. At some point, it may get so large that it would be impossible for the fuzzing to hit every single possible input combination for these, right? It's impossible. But there's no way for you to know how much it hit. Now, it does give you the percent when it runs. Like it looks at the coverage, so it does line coverage. But line coverage doesn't tell you what you don't know, right? Because if you knew about a corner case you had to handle, then you would have coded it. But you don't know it, and you're relying on fuzz testing to tell you what it is. But if your potential input space is humongous, that in reality it might take 100 years to cover, you don't know, fuzz testing is not telling you, then it would be greatly more useful to kind of, instead of UN32, this large space, to limit it, to focus on just this chunk. That way you have more confidence that all your inputs of interest are actually covered. All right, so that is a downside if you want to do kind of serious fuzz testing with a lot of inputs and a lot of complexity. And the last thing I want to mention is that it's a little hard to maintain fuzz testing, right? It gives you these files with weird formats. So people who are not aware of fuzz testing will look at these and be like, what is this? They're not going to understand. Things will fail with some inputs. They'll go to this test. They'll have no idea that they need to go into the test data fuzz directory to look for things. And if you want to move these manually, like I mentioned before, it's like busy work. In addition, if you add a new input here, right, like I did, like all of a sudden the test won't work anymore. Let's see. Let's run. And it's going to give you an error like this: wrong number of values in corpus entry. Like for someone who doesn't know about fuzz testing, they're going to be like, what is a corpus entry? What? They'll have no idea what this error is, right? That said, it's an interesting approach, and as long as you're aware of the downsides of fuzz testing, it's worth giving it a try, right? It could help you in development, especially to find your corner cases. So I'm certainly gonna give it a try, and I'm gonna try it on interesting cases like database accesses and things like that, and I will report what I find.